exception handlings are very important.
Yeah. Able to see my screen?
Yeah.
Yeah. So this is one of the powerful mechanism to handle runtime errors so that the normal flow of application can be maintained. Now, if you take a small example of a Java, like a simple Java code, let's say you have 20 lines of code there, and you're executing line by line. So if you want to alter the flow of the execution, what you use something called as control flow statements, meaning if else conditions or switch conditions, break and continue. So with these conditions, you'll be able to alter the flow. But at the end of the day, your execution should reach at the last line of your code. That is our main aim. Only then you can tell that okay, my Java program is run completely. Suppose now when you're running from line number 1 to line number 20, and in line number 10 you have some exception. Exception meaning, okay, we know that in mathematics, if any number is divided by 0, that cannot be possible because you cannot divide a number by 0, correct? So similar way,
Yeah.
if you try to divide that some number by 0, our Java will throw one exception there, stating that okay, you cannot divide a number by 0. So whatever operation you do from this line after that, it will not be executed. That means your program is not reaching the last line of the code. It is closing abruptly there in line number 10 itself. So that is not an usual like that's not a good case scenario when you're writing a code. So to handle these errors, you need something called as exception handling. Meaning, in the event of exception, what will you do? Like suppose you have written some piece of code, it is executing perfectly fine. Suppose if there is an exception there, what is the next step? It should not stop there itself because your application would be visible to thousands and thousands of users. Let's say if you're working for a very big like if your application is open to wide, like if like take a Facebook example, it is open to almost each and every user all over the world, and see if there's a small exception there, everyone will be stuck there itself. So to handle those kind of exceptions, you need to know something called as exceptional handling. So it will be so with this you can handle class not found, IO, SQL. All these are called as runtime errors. Okay? The core advantage of exception handling is to maintain the normal flow of application. An exception normally disrupts the normal flow. That is why we need to handle the exceptions. So same as our collection framework, you also have a big hierarchy for exceptions. So the uh, root interface is called your throwable interface, the throwable. Then comes your exception and error. Exception and error. So this will be implementing your throwable interface. And with this exception class, you have IO, input output exception, SQL exception. So when you're working with databases, you'll get these exceptions, SQL exceptions, class not found exception. Meaning if you're trying to import some class which does not even exist in your project, then you'll get this class not found exception. And there are many other cases also. And the other, sorry, and the other one is a runtime exception. Within the runtime exception, you have arithmetic, null pointer, number format, index out of bounds. And in index out of bounds, you have array index out of bounds, and you have string index out of bounds. So all these things will be coming under exceptions. This entire left hand tree side. On the right hand side, you have something called as an error. What is an error? So now, um, like if you have something called as an exception, you'll be able to handle it. But error, you cannot handle it. You need to again completely reboot your application. That means you need to restart your application to come out of that error. So Stack Overflow error, virtual machine error, out of memory error. So we know that each and every object, whatever we create within Java, that is stored in the heap memory. So you know, right? Like let's say if you purchase a laptop, the very first thing you ask is for your RAM. What is the RAM? 12 GB, 16 GB, 20, 80 GB, this way. Similarly, your applications will be deployed on some servers. Take it as cloud servers or Tomcat servers or any server. Server means a host. A host should have a memory and a RAM or heap size. So if like let's say if your server is provisioned with 8 GB of heap or 12 GB of heap, and whatever code which you're running, that's a very big code. Your entire 8 GB of heap will be exhausted. with all your objects, class and everything, then you'll get this error, out of memory error. So in that case, what you can do, simply restart your application. So it'll erase the entire heap. Exception means you'll be able to handle it. Error means you need to do some external steps to handle these errors. So we have types of exceptions, and there are mainly two types of exceptions. One is checked and one is unchecked. An error is considered as unchecked exception. However, according to Oracle, there are three types of exceptions: checked exceptions, unchecked exceptions, and errors. So what is a checked exception? The classes that directly inherit the throwable class, except runtime exception and error are called as checked exceptions. So the classes that directly inherit the throwable class. So IO exception, SQL exception, and class not found exception, and many more. All these are called as checked exceptions. So except runtime exception and error. So these exceptions are checked at compile time. So when we're doing a live coding, you'll get to know what are the exceptions and why are they checked at compile time. And the classes that inherit the runtime exception are known as unchecked exceptions, meaning this one: arithmetic, null pointer, number format, index out of bounds. All these are called as unchecked exceptions. So unchecked exceptions are not checked at compile time, but they are checked at runtime. What is an error? Error is irrecoverable. You cannot recover from that error. Instead, you need to simply reboot your server or reboot your application and undo the necessary steps. Java exception keywords. So whenever you're working with exceptions, right? You need to know what is a try catch block, what is a finally block, what does a throw keyword mean, and what does throws mean. Try, catch, finally, throw, and throws. These are the 5 words which will be seen more frequently when you're working with exceptions. So let me go with the checked exception. Just a minute.
And those exception Java keywords can be as a reserved keywords, right?
Which one? Which one? All these are reserved keywords. Yeah, you cannot use them.
Okay, yeah, perfect.
And we know that if reserved keyword means your editor also show it in bold.
Yeah, we cannot use those words like a class or a methoding structure also, right?
Yes, yes.
Okay.
So if you see try, it's in bold. Catch. Okay. Now so whatever class which we are writing, right? I'm just providing some documentation comments here. So a try block can be followed by one or more catch blocks. Each catch block must contain a different exception handler. So if you have to perform different tasks at the occurrence of different exceptions, use Java multi-catch block. At a time, only one exception occurs, and at a time, only one catch block is executed. So all catch blocks must be ordered from the most specific to the most general. That is, arithmetic exception must come before catch for exception. So the meaning is, now your exception is the main class, and within that exception you have something called runtime exception, and within that runtime exception you have arithmetic exception. So if you directly print exception here, you won't get what is the exact exception. But if you handle the arithmetic exception, this will tell you, okay, you're dividing something by something, that's why you're getting an exception. Let me tell you that. Just a minute. I have a main method. Again, just type tr by try, control space, you'll get this try catch block. Hit enter. Try means whatever piece of code you want to write, put in the try block. So let's say I want to write int a equal to 10, and I want to print syso sysouch. I want to print a by 0. I want to print something a by 0. Now what will happen? See, there's no output here. Let me log it. E dot print stack trace. And let me print as well. So okay. For now, let me remove the try block. Okay, till date, let's assume that we don't know what is exception handling. So I simply initialized a variable called a with a value of 10, and I want to print a by 10, a by 0 value. And after printing the a by 0, I'm going to execute some trashy code. Okay, if I try to run this, I got an exception. Exception in the main thread, java.lang.arithmetic exception divide by 0. So divide by 0 will throw you an arithmetic exception. And if you notice that this rest of the code is not executed. Rest of the code is not executed. That means my code execution stopped here itself. At Java line number 20, my execution stopped here itself. It didn't pass this line. Now I'll put a try block here. Try. That means just try to execute the statement, and in the event of exception, catch the exception. Catch ARITH. Catch arithmetic exception. Put that exception in something called as a E object, and with this E object, just print it. I just want to know what is the exception. Now see.
Oh, what it mean? Print stack tree method. Can you explain that method?
Yeah. Just hover on that, it'll tell you. Prints this throwable and the backtrace of the standard error stream. So if you want to know what exactly is the error, it will throw you it will give you a complete error log there. So I'm throwing this error because you're trying to do something. You're trying to do something. What is the root cause? This one. What is the root cause? This one. Wait, I'll tell you. Just a minute. You see this? Rest of the code is executed. That means even though my code, I have an error here, this got handled by printing the stack trace. Like it told me that okay, you tried to print something in line number 20, which is an arithmetic exception. Hence, I'm not going to execute this piece of code, but I can execute this piece of code. So your flow is not altered here. It is coming line to line. Previously, you didn't have a try catch block. So whenever you have an exception here, your application stopped here itself. It didn't execute the 25th line. Now, if you type e.print stack trace, what does this tell is your okay, let me do one thing. Let me put a debugger here. Try catch. Okay, just hover on the E. It is telling arithmetic exception. What is arithmetic exception? I'm trying to divide something by 0. This is the value. This is the exception. If you want to see this, you need to simply write this one, e.print stack trace. That's it. So whatever code you think might throw an exception, put in a try block.
So what's the functionality of catch then?
See, okay, you'll get an error here.
Yeah.
A try means what? Okay, put it in a simple English language. Try means what? You're trying to execute a piece of code.
The code.
Yeah.
When you're the code what we would like to write.
Yeah, whatever functionality you want to write, put in the try block. And when you're executing the try block, when you get an exception, simply catch it. Where in this simply catch what? The exception. Put it in E variable. And with that E variable, just print it. So that tomorrow when you're debugging the code, you'll get to know what is exact exception. Otherwise, we don't know, right? Now I know because I'm dividing something by 0, I'll get an exception. That I know. That's why I'm just simply putting it in an exception. Tomorrow we don't know, right? What is exception? Exact exception. That's a print it. So the printers will tell you, okay, you're getting an exception because of this. Did you get it? Yes, no?
Yeah.
Everyone?
Yeah, got it.
Okay. So this is a simple example. Now let's say I have int array equal to new int of 5. Now I'll let me store ARR of 6 equal to 10. Okay. So I have initialized an array ARR with a size of 5. Now I want to put 7th element as 10 value. Now see the exception. Array index out of bounds exception. Index 6 out of bounds for length 5. This is the message. At which line number? 22. So with this, you'll go to line number 22 and you'll find this piece of code. And with this message, it's telling that it is index 6, but the length is 5. So based on this, you need to fix your code. And you can see that rest of the code is also printing. That means even though I have an exception here in line number 22, it caught the exception and it resume my execution flow. That is the purpose of exception handling.
It is like a break statement, not break, jump statement, continuing the flow, right?
Continuing the flow, yeah. Don't take it as a continuous statement. It doesn't abrupt your flow. It doesn't stop your flow. Take it that way.
Okay.
Okay. So now see, I have int array of 5, int array of 10. Now we know the exception hierarchy, right? Int equal to 5 and I have something called as 5 and I print something like array of 10. So I'm getting an array index out of bounds exception. So where is this array index out of bounds exception? If you see, it is here, array index out of bounds exception. So what is the top level class of this arithmetic exception? So if I try to catch arithmetic exception on top of array index out of bounds, this will be caught. That is for sure. Now let me comment out. Let me comment out this. This will be a bit tricky, but it's easy only.
Bhavan?
Yeah.
See, here you are giving E variable, right, after exception.
Right.
So it doesn't mean it shows the address of that particular exception in heap memory, right? So here you are giving for every exception E same variable. So it automatically refers to the same variable. The same variable it's constant all the exceptions in heap memory.
See this. At a time, only one exception can occur, right? Only one.
Okay.
That means what? Only
Mhm.
one catch block will be executed.
Okay.
You can have hundreds of catch blocks, but only one catch block will be executed. That means
Mhm.
only one E would be initialized there. Even though I give a same name, this will not be initialized, right? Because this won't be executed. It's only one catch block which will be executed.
Okay. Got
Correct?
it.
Yeah.
Yeah.
Now previously I got arithmetic exception because I caught the arithmetic exception first. But now I'm trying to catch array index out of bounds exception. So if I run this will be caught.
Mhm.
Right? Now
So
let's
at a time only one exception will
yeah.
be occurred.
Yeah.
So it doesn't matter about the you given the same variable to remaining things, right?
Yeah.
Okay, got it.
And if you run this one, here parent exception will be occur. Here, like suppose if you don't put arithmetic and if you don't put array index out of bounds, and if you give a normal exception E, then also it will be handled because this is a parent exception. only from your parent exception class only you're getting arithmetic and array index out of bounds exception, right?
Yeah.
So that's the meaning. So if you have 3 catch blocks, only one among 3 will be executed. If you have only one, that will be executed. Clear? Then is equal to null. Yeah. So within your when you're writing your source code, the most frequently common error which you can see is your null pointer exception. So lots and lots of developers will they keep on doing the null checks so that they won't get into trouble. Because now let's say you have a login form, okay, login or a sign up form or any form, and your form has multiple multiple values. Just a minute. So let's say this is just a simple form, okay? You pass in first name, you pass in last name, your mobile number, and you pass in password, and let's say you don't fill up these ones. Now, now what is the backend code which will be getting it? So in your backend you'll write, okay, string first name equal to first name, string last name equal to last name, string email equal to email, string password equal to some. You'll get the password from here, and you'll get the date of birth, and you'll write string gender equal to male, female, or custom. So your code will be expecting some of the 3 parameters there. But let's say that user did not provide any of this, and he just clicked on sign up. We know that if you don't assign anything to a string, the default value is null. So what will happen is your gender in your backend code will be initialized to null. Okay. Now see the effect. Let's say string s equal to null. I initialize the value to null here. Now if I try to do any operation with this s value, see the exceptions, null pointer exception. Let me pull e.print stack trace here. This one. At line number 38. What is 38? This one. So if your object is null or if your variable is null, and only if you want to do any operation with that null value, you'll straight away get a null pointer exception. That's why it is always a very good thing to do a null check. If s not equal to null, print it. Now in this case, you'll not even get an exception here. Rest of the code, it directly go to this code. So this is called as a null check. Did you understand this? Yes, no. I know this is a tricky concept, but just tell me if I can repeat it.
Once repeated.
Okay. Did you understand this? Like, what is a null value?
Yeah.
Let's say you have a simple sign up form, and whatever values you provided here, these values will be provided. These values will be given to your backend.
Yeah.
From your front end. From front end, it will come to backend, and then backend values will be assigned simultaneously. So let's say string f name, string f name, string l name, string last name, okay, and put this as string gender. And some user did not provide the gender. Take it in that way. So, and if there's no value, and you know that each and every data type will have a default value, right? If you don't initialize something if you don't initialize it, you'll get a default value. For integer, it is 0. And for a double, it is 0.0. Similarly, for string, it is null. So from the front end, if you don't get the gender value, it will be automatically initialized to null. Not a blank string, it will be initialized to null. And if you want to perform any operation with this null value, What is the operation which I'm trying to perform? I'm trying to get the length of my string. So gender dot length, that means this length is a method. This method is trying to return me an int. What is the int value? The length of the string. And I'm trying to perform an operation on a null value, which will straight away throw a null pointer exception. This way. Is clear? No? No?
So if they're not given first name means,
Mhm.
so what kind of exception it got? Even after it will get null pointer exception only, right? Because in Java by default value taken as null. So user, they are not giving first name,
Mm.
rather they're giving only last name, and
Mm.
he continue the remaining forms to fill. So
Mm.
at that time, exception would be null pointer exception only, right?
Exactly. But I just gave an example. But in real case, you see this, it will not even allow
Mhm.
you to sign up until unless you give your mandatory fields here.
Yeah.
Correct?
So it means in backend it is showing null pointer. When it
Mm.
is running, it shows null pointer irrespective of any column.
Mm.
If they missed the data means it
Mm.
shows the null pointer exception, right?
I gave you a general use case for a null pointer exception. That can be any exception if you miss a data.
Oh, yeah, exactly.
Mm.
Yeah,
So
got it.
yeah. So now, if I don't have a catch block, what is my error? Let's say I'll put it here. Okay. Let's say string s equal to null. Let's say I don't want to use a try block. Okay. Sysout s dot length. Okay. Let's say I don't have any now. These two lines are not in the try catch block. If I run this application, my rest of the code is not executing. So what will happen if I just click on save, my gender value, take the gender as example, gender value is null, and I'm trying to calculate the length of the null value. My program abruptly stopped here. There's nothing I can do with this now. But instead, if I put it in a try block by handling the null, what it will tell in the backend, it will tell that okay, it's a null point exception, and it will simply execute the rest of the code. And we know that now with this previous example, I want to catch arithmetic exception, array index out of bounds exception, null pointer exception, and an exception. So this is the hierarchy. It will first now, if you try to calculate null dot length, it will obviously throw null pointer exception. So it will check for arithmetic exception. Now, if you go to diagram, arithmetic exception and null pointer exception. So these are under the runtime exception class. Okay, so whatever exception I got, that's not an arithmetic. So it will go to the next catch block. In the next catch block, I'm trying to catch array index out of one exception. So even that's not the exception which I want. In the next catch block, I'm trying null pointer exception. So this is the exception which this is trying to throw. Hence it printed out null pointer here. Null pointer. So if you want to put multiple catch blocks, each catch block should catch different exceptions. Clear? Still in dilemma?
No, I'm
No?
clear.
It's clear, right? Yeah. So how many ever catch blocks you have, you need to catch different exceptions, and based on what exception it is throwing, it will try to catch each and everything. So at this point of time, only this is caught because this is a null pointer exception. Suppose if I don't have this whole block, what will happen? Parent exception will be occurring because my exception does not come under arithmetic. It does not come under array index out of bounds. It will come under exception. This is the parent class. If this is clear, right? The try catch block.
Yeah.
And now let's take a look at the find new block. Java find new block is used to execute important code such as closing in the connections. Now let's take array. Within our arrays, we discuss something called as a scanner. What is a scanner? Like if you want to take some input from your console, you'll open the scanner class. So if I don't use this line, you'll get something called as a scanner here. A small warning here. Resource leak, the scanner is never closed. Meaning we opened a scanner class and we did not close it. So that's the warning. So after your operation, you need to simply close it. Or try with resources. So this is a real-time scenario, like wherein if you're trying to use a simple scanner, or if you're trying to use a simple file input or file output streams, you need to close them. So that is so to close all those things, you'll use a finally block. So let's say scanner equal to new scanner, and enter I'm just printing enter a string in equal to scanner.next. Scanner.next means it is reading some input from a console, it is storing to in variable. Now let me put something called as int data equal to 25 by 5. So here you won't need any exception. So system.out.println, and I'm just checking for a null pointer exception. Finally, yes.
Actually, I don't know about the string in is equal to scanner.nest. So can you explain that one? I know,
Okay.
like when you user want to give input to the system,
Mhm.
so this scanner object is going to be created. So some object allocation is maintained in heap memory.
I'll
So
tell you.
what's the meaning of string in is equal to scanner.nest?
Okay, I'll tell you. So you know why do we use a scanner class, right? To take input.
Yeah, user inputs.
Yeah. So and as a user, you know what input to give. You know how to provide a string. You know how to provide an integer. But we need to tell Java that okay, I'm providing a string value, so accept that value as a string. I'm providing an integer value, so I accept that value as a integer.
Mm-hmm.
So now let's say string s equal to scanner dot next. If you type this way, see the data type here, it is a string. That means my s will hold a value of string. Int a equal to scanner dot next int. Next int is of type integer. So the next line, whatever I provide, it will be stored in a of type integer. SISO. Values are s. Values are s. Let's see. SISO. Enter value. Enter values. What happened? Okay. If you see enter the values, what is the first value which I'm trying to give? It is scanner.next. So I should provide something. The next value is 23. The values are FDS and 23. And it will terminate here. Now let's say I run the application, and the first thing my scan is expecting is a string. If I provide 23 here, and the next thing is something like this way, it will throw an exception here. Input mismatch exception.
Okay. So
Clear?
if it is a double,
Yeah.
if I'm entering double value,
Okay.
so we supposed to write scanner.nest double, right?
Yeah. See this. Double B equal to scanner dot next double.
Okay. So here
Clear?
it's
Mhm.
okay.
Go ahead. Yeah.
Usually double start with small small case, but here this method getting double. Okay, I thought it comes under wrapper, but not no. Yeah, we can go ahead. It's not my doubt. I got clear.
Okay. So now if you see just a minute. So scan equal to new scanner. I'm just asking it to enter a string, and then whatever this is next, right? So next means it's a string value. So in is a string value, and string entered is you'll get the string. Now you'll try to execute something. Okay, system data plus put a plus symbol, give some space, and print the in value. And I don't want this. Now I just put some code within the try block. So 25 by 5 will never throw an exception for me. But suppose if it is throwing some exception, catch it. Where here as an null pointer exception, you just catch it. Then put a finally block. Try, catch, and finally. Finally means irrespective of like even though if I get an exception here or if I don't get an exception here, this block will be executed. That's the meaning. So if you get an exception within the try block, then this line will be executed. The catch block will be executed. But if you don't get any exception here in the try block, this will never be executed. So even though you get an exception or you don't get an exception, finally block will be always executed. So enter string, okay, put some trashy value. I get a 5 value, then the string is printed here. Finally block is always executed. This is my line. It is printing, and the rest of the code. So why did I use a finally block? To close my scanner. Scanner.close. Now if I don't put a scanner.close, I'm getting a warning here. Resource leak. The scanner is never closed. That's why close the scanner simply. Put scanner.close. You won't get the warning. It'll make your code look more cleaner. Clear? Yes, no?
Yeah.
Yep. Thank you. Now
This topic is quite complex.
I thought of like literally completing this and go to threads concept. But yeah, I'm going slow. That's okay. You should only know the main idea behind it. What is the main idea? Whatever is my scenario, my execution should never stop. That's it. Do whatever we want. So what is the weapon we have? Exception handling. How to do it? Using try catch block. Use that within the so whatever piece of code you feel that it's going to throw an exception, put in the try block. Now you know that it's going to throw an exception, right? It might throw an exception. Put that exception in the catch block and catch it. So now see here. I have something in the try block. What I'm doing in the try block in data equal 25 by 0, and I want to print the data. So obviously at this line, it will simply stop my execution. I wanted to catch a null pointer exception. But what is exact exception? It is arithmetic exception. So it simply stopped here. Final block is this rest of the code is not executed. See here. So that means you cannot write whatever exception we want in the catch block. We should clearly know that okay, what type of exception would be thrown in the event of in the event of this execution. If you don't know what is exception which it is going to throw, simply put a parent class exception. See. If you put the exception of the parent class, then your rest of the code is executed. So only use this exception if you don't know what type of exception that your code might throw. 25 by 0 is a arithmetic exception, but you're trying to catch a null pointer exception, so it won't allow you. That's why you got this exception here, and your rest of the code is not executing. So what is exact meaning? So even though you put a try catch block, and if you put that doesn't assure that your rest of the code will be executed unless and until you catch the correct exception. Is this concept clear?
Yeah.
No? If
Yeah.
not, I'll explain it again.
Once. Yeah.
Okay. So let's say now I have a try block. Within the try block, I want to execute this piece of code.
Yeah.
And I want to assign some value to data. What is that value? 25 by 0 is the value which I want to assign to data. And from my mathematical knowledge, we know that you cannot divide a number by 0.
Yes.
So it will straight away throw an arithmetic exception. That also you know, right?
Yes.
So if it is throwing arithmetic exception, what you need to catch? You need to catch the arithmetic exception, right?
Yes.
But what am I trying to catch here? Null point exception. This exception is never thrown. So what it will do? So even though I used a try block, I used a catch block, and I cannot assure you that this piece of line will be executed.
Okay.
From the starting of our class, what we told that okay, you can handle an exception by using a try catch block. That is what I assured you. So whenever you use a try catch block, the rest of the code will be executed. That was our first statement. But now, even though you provide a catch block, and if you don't provide a correct exception there, this piece of code will never be executed, because you're trying to do some data, you're trying to do some operation which you know that it will throw an arithmetic exception, but you're not catching it. You're catching an null point exception. That's why it's not allowing you. Simply catch an arithmetic exception here and try to run the code. Then the rest of the code will be executed. So writing a try catch block alone will not help us. You need to catch the correct exception. If you don't know what is the correct exception, simply catch the main exception, because whatever exception you have, everything will come under the main exception class here. Catch this exception.
Okay.
Right?
So in the worst case, if we don't know what exactly,
Yes.
then we can keep okay.
Put the exception class.
If we keep arithmetic one, it will get right.
Yeah, if you put arithmetic exception, you'll get it, because 25 by 0 is an arithmetic operation, and divide by 0, obviously it'll throw an exception. It'll catch it.
So what is the difference? I mean, irrespective of arithmetic or just an exception, anything will generate a output code correctly. Then what is the difference of keeping both? I mean, either that or this.
Your main exception class won't provide you much information on your exception.
Okay.
Now here it is simple divide by 0. Tomorrow when you're working, right, those are like you can call them as wild exceptions itself. Wild, like you'll get lots and lots of lines of errors within your same one line of code.
Okay.
So for you to debug them, you need to get an exact trace from where a exception is starting and where it is ending. So for that, you need to catch exactly that exception only. Okay. So suppose if you want to catch both of them, put null pointer here. It execute. We know that we can have multiple catch blocks. And if you're unsure that okay, I don't know if it is arithmetic or null pointer, then put an additional catch block with exception E. Parent exception. You can write it this way also. We know that even though you have multiple catch blocks, only one catch block will be executed. So put arithmetic, null pointer, and exception. Whatever will be caught, that will be executed. And even though you have an exception or not, the final block will always execute. That's why I got this piece of line here. Clear?
Yes.
Everyone, is this clear? I know that
Yeah.
this is, yeah. You, Asha?
Yes, Pawan, it's clear.
Okay, thank you. So we know try, we know the final block. What is an exception class? Yeah, that's fine. Nested try. So you can, like how we have an if and an if, you can have try, and a try. That means this is a try block, right? Now in your Eclipse, you have something called like if whenever you just click on the outer opening brace, if you double click on that, the complete block will be selected for you. So it will be very easy for you to work with blocks. So if I just double click on this one, this block will be selected. If I double click on this block will be selected. Similar way, if you want to work with blocks, right? Simply double click on the open and close brackets. You'll get to know what is the exact block of code. So I have a try block, and within the try block, I'm trying to print something called as 13 by 0. So for this try block, I'll write a catch block, arithmetic exception.
So if it is not arithmetic exception, it will go to another tribe, right?
No. Just keep in mind that if you're working with a single try catch block, your execution is limited only to the try catch. So whatever exception this try is throwing, only that will be caught by this catch block. It will not go to the next catch block.
Okay.
Right?
So
I'll tell.
next try box will execute until it going to be clear. First one.
No, right? That is my whole concept of exception handling, right? So even though I get an exception here, this should execute for me.
Okay.
Right?
Yeah, got it.
Yeah. So I have now here. This is the next try block. I have a array of 5 elements, and I'm trying to add a sixth. I'm trying to add it in the sixth index. Yeah, 5 is sixth index, right? So here I'll get an index out of bounds exception. So for this try block, I'm going to catch it. Now, if both the catch blocks, like if I'm not able to catch both exceptions, then what will happen? I have the parent try block here, right? This parent try block will have a catch block here. Here I'll get the exception. So these exceptions will be handled outside. You'll get it? Wait, I'll tell you. Okay. The very first line going to divide by 0. It went to divide by 0, and I'm trying to print b with 13 by 0. So I got an arithmetic exception, divide by 0. Then it went to this one at line number 20. I tried to add something. I got an index out of bounds exception because I'm trying to add a fifth element for length of 5. Not possible. Then I got this other statement exception, other statement. After that, now since both exceptions are handled here itself, arithmetic and error index out of bounds, there's no error. There's no error in this whole piece of code because these are already caught. So this catch block will not be executed now, and it will simply print the normal flow. Suppose, let's say I have now I know that I'm going to throw an arithmetic exception, but unknowingly I caught a null pointer exception. What this will do? See the flow now. Going to divide by 0, but here I caught a null pointer exception instead of arithmetic exception. So it simply went out of the block and it executed this one. Handle the exception in the outer catch block, and it resumed the flow. Did you get it? Try and try catch block. Yes, no?
Yeah.
Yep. Uday, what about you?
Yeah.
Yeah, okay. Darbabu?
Yeah.
Yeah. So this is a simple block of code. This is a simple block of code. If these two block of codes have some exception, that will be caught in the find exception. If you want, let me simply debug it. This. See this? Now I'm trying to print this one line. So it printed going to divide by 0. Now I'm in line b equal to 13 by 0. So obviously 13 by 0 is an arithmetic exception. So, but I didn't catch for the arithmetic exception. So I have an error in this block. And we know that if you have any error in the try block, it will simply go to the catch block. Of which block? This is the try block. It went to catch. See the exception. You're trying to divide something by 0. That's it. It handled the exception in the outer catch block and it printed the normal flow. That's it. Suppose if I add arithmetic here and try to debug it. See, because 13 by 0 is catching an arithmetic exception, right? So it printed the exception. Now it went to the next try block. And I'm trying to assign a value which is not even in the bounds. So simply it will throw an index out of one exception. Other statement. So these two blocks of code executed completely. That means there is no error within this piece of code. So this block will never be executed. It will directly go to this line, normal flow. Only if there is an error within this block, this catch block will be executed. Clear?
Yeah.
Yep. So if you have any issue, if you have any doubts still here, please let me know. We can resume the remaining concepts on Monday.